Hey guys, this looks like a fun one. We're given 3 squares inside of a larger square, and it wants us to find the size of this angle. If you want to try it on your own, pause it right now, because I'm going to solve it in 3, 2, 1. First, let's label this angle alpha and this angle beta. Since this large figure is a square, this is going to be 90 degrees. So that means we can say alpha plus beta plus question mark is equal to 90. This looks important. Let's put a box around it. Next, we can label some more things. I do not know how big this is, so let's call it X. And the side length of each of these little squares, Y. So this will also be Y, because it's another side of this square. And these are all going to be Y. And then this part of this square is the same as this, so it's Y, and this will also be Y. Does that make sense, Y? And then for this portion of the right side, it's going to be equal to this X plus Y. And we can also find the length of the top. This side of this square is X plus 2Y. So the top of the square is also going to be X plus 2Y. So now what are we going to do with this? We got to do something with the alpha and the betas and these X and Y's. Well, I'm noticing this alpha makes a triangle that has X plus 2Y up here and an X right here. And it's going to be a right triangle because this is a right angle of the square. And same thing, this beta also makes a triangle, and it's also going to be a right triangle, and it has side lengths of X plus Y and Y. So for this triangle, we know the side opposite the alpha and adjacent to the alpha. And for this triangle, we know the side opposite of the beta and the side adjacent to the beta. Tangent is equal to the ratio of opposite over adjacent, so we can do the tangent of each of these. The opposite of alpha is going to be the X, and the adjacent would be the X plus 2Y. And then for this one, the opposite of the beta is equal to Y, and the adjacent is the X plus Y. And now we have values for tangent alpha and tangent beta, but we're really interested in alpha plus beta. Luckily, we have the sum and difference angle formulas for all of these trig functions. In this case, we're going to be interested in this one here. Tangent A plus B is equal to tan A plus tan B, whole thing divided by the quantity 1 minus tan A tan B. Let's do this. So for tan alpha plus beta, it's going to be tan alpha, which is X over the quantity X plus 2Y, plus, and then tan beta is Y over the quantity X plus Y. And then we're going to divide all of that by 1 minus the tan alpha, which is this, times the tan beta, which is this. And now let's clean this up a little bit. Let's give ourselves some room, and on top, let's give these a common denominator. On the left-hand side, we'll multiply top and bottom by X plus Y. And on the right-hand side, we can multiply top and bottom by X plus 2Y. And same thing on the bottom here, let's give these a common denominator, so we can multiply the top and bottom of this 1 by X plus Y times X plus 2Y. Now we can multiply a whole bunch of stuff out. We have X times X, which is X squared, and Y times X, which is XY, and then another Y times X, which is XY, and Y times 2Y, which is 2Y squared. And then on the bottom of this, we have the common denominator of X plus Y times X plus 2Y. And then for this down here, X times X is X squared, Y times X is equal to XY, X times 2Y is equal to 2XY, and Y times 2Y is equal to 2Y squared. And we're still going to subtract this XY. And on bottom of this fraction is this common denominator X plus Y times X plus 2Y. Now let's clean this up a little bit. XY plus XY is equal to 2XY, and this positive XY and this negative XY can cancel each other out. So now we have a fraction where the top is the same thing as the bottom. So this is going to fully simplify to 1. Now, because of all this work, we've shown that tangent of the quantity alpha plus beta is equal to 1. And once again, tangent is the ratio of opposite over adjacent. So if we construct a right triangle where we have the angle alpha plus beta here, the opposite side here, and the adjacent side here, this is only going to be possible if the opposite and the adjacent are congruent. And this is only going to be possible in a 45, 45, 90 triangle. So this alpha plus beta has to equal 45 degrees. And now we're basically done. We can go back to the boxed equation and copy it down here. And in the place of the alpha plus beta, let's plug in 45. After we subtract 45 from both sides, we get question mark is equal to 45. Let's give it a label of degrees and put a box around it. And this is the answer to our question. In this diagram where 3 little squares are inside of a larger square, the question mark angle is always 45 degrees. How exciting. This feels kind of weird to me. That means this square could be anywhere. It doesn't have to be halfway or anything. I think I want to use some technology to verify this. So here's the GeoGebra calculator suite. Let's see if we can reconstruct the figure and verify it's 45 degrees. So for the first step, let's find the regular polygon and make this square with 4 sides. And then we can make the one next to it just like this. Now to do the other square on top, we need to pick some point at random. Let's do this point right here. And let's connect the segment from here to here. Now off of F, I want to construct the parallel line to this line. And then let's extend this top part right here. So then we can find the intersection of these 2 lines and let's construct this polygon. And now we have the 3 polygons. Now I want to construct the large square around these 3 squares. So let's extend this line here and this line here. And let's find that intersection point. This is the base of our square, so we can now use the polygon tool again to make this square. And now we have the squares. So let's clean things up a little bit. We can use the selection tool and let's get rid of some of this stuff. Oh, I missed this line. Let's do this too. Okay, now we're good. So now it's cleaned up and this should be able to move around. Now we can draw the angle. Let's draw this from here to here and this from here to here. And let's measure the angle. And it says 45 degrees. Let's move this over here and clean these up a little bit. And now we can slide it and we can see that it's always equal to 45. So no matter where we slide this square to, the question mark angle is always going to be 45 degrees. That's pretty cool, huh? How exciting. And here's the next challenge problem. We need to simplify this nested radical. It's the cube root of 9 times, 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 going on forever. This looks like it's definitely going to be a fun one. How exciting.